In this second module, we will explore biological processes, sludge handling, treatability studies, and the importance of practical exposure through site visits to treatment plants. Biological treatment is vital because it deals with the bulk of organic pollutants in wastewater, while sludge handling ensures safe disposal of treatment byproducts. Section 1: Introduction to Treatability Studies. Before designing a treatment plant, engineers conduct treatability studies to determine how well a particular wastewater responds to treatment. These studies help to identify the most effective unit processes, estimate operating cost, predict the efficiency of pollutant removal. Treatability studies form the bridge between theory and practical application. Section 2: The activated sludge process. One of the most widely used biological methods is the activated sludge process. In this system, wastewater is aerated in a tank containing a suspension of microorganisms. The microorganisms consume organic pollutants as food, breaking them down into simpler substances. After treatment, the biomass, sludge, is settled out, and part of it is recycled to maintain microbial activity. The process is flexible and can achieve high removal efficiencies but requires careful control of aeration, sludge age, and oxygen supply. Section 3: Biological filtration. Biological filtration uses fixed media, such as rocks, gravel, or plastic, on which microorganisms grow as biofilms. As wastewater passes over the media, the biofilm consumes the organic matter. This process is simpler and requires less energy than activated sludge, though it may be less efficient for very strong wastewaters. Section 4: Stabilization ponds. Stabilization ponds, also known as lagoons, are large shallow basins where wastewater is treated naturally through a combination of sunlight, algae, and bacteria. They are inexpensive and simple to operate. They require large areas of land, which limits their use in urban settings. They are effective in tropical climates like Nigeria's, where sunlight is abundant. Section 5: Anaerobic sludge digestion. Sludge is the unavoidable byproduct of wastewater treatment. To reduce its volume and stabilize its content, anaerobic digestion is often employed. In this process, microorganisms break down organic material in the absence of oxygen. The end products are biogas, mainly methane and carbon dioxide, and a stabilized sludge that can be more safely disposed of. The biogas can even be captured for energy generation, turning waste into a resource. Section 6: Sludge thickening and disposal. After digestion, sludge still contains a lot of water. Thickening reduces the water content, making it easier to handle. Methods include gravity thickening, flotation thickening, and mechanical means like centrifuges. Disposal options include land application as fertilizer, when safe, landfilling, incineration, in some cases. Safe sludge management is critical for protecting public health and the environment. Section 7: Site visits and practical exposure. No lecture or textbook can fully substitute for a site visit to a water or wastewater treatment plant. These visits provide direct observation of processes in action, understanding of operational challenges, appreciation of the scale and complexity of treatment facilities. Students gain practical knowledge of how theoretical concepts are applied, preparing them for future roles as engineers. End of Module 2 Summary. In this second module, we explored treatability studies as the foundation of design, biological processes such as activated sludge, biological filtration, and stabilization ponds, sludge treatment and disposal methods, including anaerobic digestion and thickening, the importance of site visits for bridging theory and practice. In this course, Unit Processes in Water and Wastewater Resources Engineering, we have examined the key principles and applications of treatment processes. Module 1 focused on reactor engineering and physical-chemical processes such as equalization, flotation, iron and manganese removal, water softening, and taste and odor removal. Module 2 covered biological treatment methods, sludge management, and the role of treatability studies and site visits. Together, these modules provide a comprehensive understanding of how water and wastewater can be managed to protect human health and the environment. As future engineers, your challenge is to apply these principles to real-world problems, designing systems that are both effective and sustainable.